this go. Hey there. Well, we're going to do this last section, 10.5, and it's actually has two parts to it. What we're going to do is we're going to skip this 1 through 4 for right now, and we'll come back to it. What we're going to first review, this first part will be a review of our 10.2 and the rules for multiplying these terms together here. And what do you do with the exponents? And so this first part will be kind of a review. It'll be a little bit different when we get to 11, but not much. So let's go ahead and get started with number 5. And like I say, we'll come back to 1 through 4. All right, when you multiply these two together, all right, you multiply the coefficients. So that gives us 32, and then we have common base, x, and you add the exponents. 1 plus 1 is 2. Remember that if the exponent's not there, it's a 1. So we multiplied coefficients, and then we add the exponents on our common base, 32x squared. Let's look at number 6. Multiply the coefficients, -2 times 3, -6, common base of x, and you add the exponents, 4 plus 1. It's really easy to forget there's a 1 there, so try not to do that. Now, if we were adding, obviously we could not add these together because these don't match, these terms don't match, but you can multiply them because the only thing that has to match when you're multiplying these are the bases, okay? And then you add exponents. So don't get the adding of these terms with the multiplying of these terms. So we can go ahead and add the exponents when you're multiplying a common base. Okay, let's look at this next one. We'll multiply the coefficients. 0.6 times a -0.3 will be a -0.18. Okay. Looking at our bases, we have both of them have an x, and we'll add the exponent on the x's. 6 plus 2 is 8. So it's kind of nice to go back to this multiplication, just so that you can keep these rules straight. Number 8, a couple different variables, no problem. We're going to go ahead and multiply the coefficients in front. That gives us 20. We have an x. We'll add the exponent on our base of x. 4 plus 6 is 10. Then we have a y. I'm putting these in alphabetical order as I list them. And then on the y, I have a 2 and a 7. So we have 2 and 7. I add those together and you get a 9. So there's your answer. That's all you can do. Let's try the next one. It's really not so bad. 5 and 8 are the coefficients, so we will multiply those numbers in front. That gives us 40. Okay. We'll start with x. We'll go in alphabetical order here. 6 plus 2, those are the exponent on the x's. 6 plus 2 is 8. Then our next one, y. We have a 2 plus 4 is 6. Z, 5 plus 3 is 8. And there's your answer. Multiplying coefficients, adding exponents. Now again, we would not be able to add those together. If I had a plus sign in between those parentheses, they'd have to stay separate because the groups don't match. So, but we could multiply them and then add exponents. All right, let's look at this next one. 4x squared times a -3x to the 5th times a -2x to the 5th. Let's multiply the coefficients. 4 times a -3, which is a -12. That answer times a -2. So a -12 times a -2 is a +24. I knew it was going to be positive because I have 2 negatives, which is even number of negatives, which will be positive. X. Add the exponents. So we've got 2 plus 5 plus 5 gives us 12. When you add those exponents on the X, there's your answer. And that was just kind of a quick review of our section 10.2, the multiplying. If we had been dividing, we would have been subtracting exponents, but we're not doing that in this section. Okay, let's look at this one. This one's a little different. We've done the distributive property before. We just haven't done the distributive property with variables. So now we can. So we know you cannot add those two together inside the parentheses. If we could, we would, because you do what's in the parentheses first. There's nothing we can do. They're not like. The 5 does not have an X. So we're going to take and use the distributive property. We're going to take that times and that times that. So we'll take 3x times 2x and then 3x times the 5. We're multiplying. When you multiply, you add exponents. So when I multiply 3x times 2x, I get 6x squared. They're not there, the 1 and the 1, but they are, even though they don't write them. You can write them in if you want to. 1 plus 1 is 2. You add exponent when you're multiplying bases. Plus 3x times a +5 is 15x. And yes, that x has to go along. So it would be 15x. All right. So you can try the next one and then you can pause it and try the next one and then I'll do it and you can check it. Okay, we're going to take 2y times everything in the parentheses. 2y times a -1y is a -2y squared, adding the exponents. 2y times a -4 is a -8. 2 times 4 is 8. And yes, the y stays. There's your answer. Okay, very good. Let's practice some more of these. 4 more of these. My little dog, sorry. Okay, no, okay, sit down. So we're going to take this times this and this times this. Okay, so we're going to use the distributive property, adding exponents as we multiply. So a -4x squared times x cubed gives us a -4x to the 5th. This -4 times 2 gives you a -8x squared. Okay. All right. So here. Okay. So I'm sorry, I had to pause it there for a second. But all right, just remember that the x squared, when you multiply it by the 2, it stays there. So don't forget about that. Okay, let's do the next one. Okay, we're going to take this times all 3 of what's inside. And because we're, 4 of them, excuse me, 4. And because we're multiplying, we'll be adding exponents. So we'll start with the first multiplication. 5a to the 4th times 4a cubed will be 20a to the 7th. Okay. Then we'll take 5a to the 4th times a -2a squared. 5 times a negative 2 is a negative 10. A4 plus 2 is 6. So you multiply coefficients, the numbers in front, but you add exponents. Then we'll take 5a to the 4th times 3a. That will give us 15a to the 5th. Okay, don't forget that there's a 1 on that a there. 4 plus 1 is 5. And the last one, 5 times a minus 6 is a minus 30 a to the 4th. That a to the 4th does go with that last term as well. And there's your answer. And it's also in decreasing power, which is awesome. Let's try another one, or actually 2 more, and then we'll do the next part, which is going to be going backwards of this process, but we'll take and distribute this throughout the entire polynomial inside the parentheses. So a negative 2x times 4x cubed is a negative 8x to the 4th, adding exponents, so 1. And then negative 2 times a positive 3 is a minus 6. X to the 1 plus 2 is 3. Negative 2 times a negative 6 is a positive 12. X to the 1 plus 1 is 2. Negative 2 times 12 is a negative 24. X. That X stays with it, with the negative 2. All right, there's your answer. One more. This times both inside. 3 times 5 is 15. A to the 5th. B to the 2 plus 1 is 3. Then you take 3 times a minus 2 is a minus 6. A to the 2 plus 4 is 6. B 2 plus 3 is 5. And there's your answer. Okay, well, that's not too bad. The next thing we're going to do is the very beginnings of what's called factoring. And factoring can sometimes be difficult for students to understand. And again, we're only going to be doing the first step. And in your other classes, you'll continue on with future steps. What we're going to be doing in here is I have a few notes and then we'll come back to this sheet. What we're going to be doing is what we just did was we took the 3, this outside, times what's inside. And we came up with this. 3 times 6 is 18x, 3 times 5 is 15. When we factor comes from breaking apart. It's like a fracture. Think of it as like a fracture. You're breaking something into parts. When you break it into parts, you can analyze it better and you can solve it easier. So you need to learn to break a polynomial, a long strand, into different parts, different multiplications. So what we're going to be doing now when we factor is we're going to be going from here, we're going to be going backwards and making it look like this rather than like this. So you're going to be given this and told to factor it and make it look like this. Now, in order to do that, you need to be able to find what's called the greatest common factor. We spent quite a bit of time with the least common denominator. Now we need to look at the greatest common factor. The greatest common factor, it's common for one thing. It has to be in everything in our polynomial. And it has to be the largest that's in common, which, and we'll talk about that. So we want the greatest common factor. The key is common. It needs to be in all of them. All right, so I've come up with some easy ones, and then we'll go back to the sheet and look at these. And I'll try to keep the homework where it's not too difficult. But what you need to ask yourself is, what is, looking at the 15 and the 10, is there anything that would go into 15 and would also go into 10 evenly? What's the largest number that can go into them? Well, I know that 15 goes into 15, 3 goes into 15, and 5 goes into 15. 10 goes into this, 2 goes into this, and 5 goes into this. So the factors, the individual factors, I've got a 15, a 3, and a 5. And this one, I've got a 10 goes into that, 2 goes into that evenly, and a 5. The greatest common factor is 5. That's the largest number that goes into both of them evenly. And most of you probably just did that in your head. Well, 5 is what will go into both of them. So what we're going to do is that's how we come up with that number out in front, is by looking at what's in common here. And it's a 5. Now, to find out what's inside, here we multiplied. So to go the other direction, we're going to divide. What's 15 divided by 5? Well, it's 3, and then you still have the x. So this divided by this will tell you. Another way to look at it, I know that when I multiply it through here, you come back. I need to be able to multiply this out and come back to the original. What do I multiply the 5 by so that I get 15x? Okay. You can either use division to find that, or you'll know that 5 times 3x gives me that. Plus, what times 5 gives me 10? Well, to find out what times 5 gives you 10, just divide it. 10 divided by 5 is 2. There's your answer. You check them. Make sure you always check them just in case. So this times this is 15x. This times this is 10. And that's your factoring. And we have a bunch to practice. Let's look at this next one. Oh, what's in common? Well, first off, look at the coefficients. What's the largest number that will go into 6 and 12 evenly? Well, some of you say, well, 2 goes into both of them. Sure, but is that the largest? 3 goes into both of them. Sure, but is that the largest? What about 6? Does 6 go into 6 and 6 go into 12? Yes, it does. So we're going to go ahead and take out a 6. Okay. But what else do they have in common? Well, they both have an x. Well, to figure out which one, you always take the smaller one. Just like we didn't take 12, we took the 6. You take the x to the first. So you see what's in common, and then of the variables, and you always take the least one, the smallest of those. All right, and now we're done with that part. The 6x is called the greatest common factor, because it's what would go into both of those. It's the largest number that would go into both of those evenly. All righty, now, and again, we're just touching on this, kind of giving you an introduction to this, and you'll spend more time in your other math classes on perfecting this. I just want to introduce it to you. All right, so let's come up with what's inside the parentheses. What can I multiply the 6x to get 6x squared? Well, I've already got 6 times 1. 6 times 1 will give you the 6. X times x will give you x squared. What if you, that's hard coming up. It's a little confusing to come up with that. What's another way? Take this 6x squared and divide it by this. And that's another way of coming up with this. And by the way, I wouldn't put the 1 there. I just did it for your purposes. If I take this divided by my greatest common factor, that'll tell me what I put there. They cross off. We subtract exponents. 2 minus 1 is x to the first. That's it, x. In fact, I think I might get rid of that 1. This times this, adding exponents, gives you this. 12x divided by this. So let's take 12x divided by 6x. Well, the x's cancel. 6 goes into there once, 6 goes into there twice. Looks like you're left with just a 2. Multiply it and make sure you come back to the original. And you do. So if you take 6x times x, 6x squared. 6x times 2, 12x. Okay, let's go to the next one. Looking at this here, look at the coefficients first. What's the largest number that goes into both 4 and 2? Well, it's a 2. 2 goes into that and 2 goes into that. I have, what else is in common? Well, I got x's are both in common. You always use the smaller. So I will use x to the first. They're in common, you use the smaller one. The y's. What's in, they both have a y, and the smaller is y squared. So it has to be in common, and you use the smaller of what's in common. Okay. So now we'll go ahead and we're going to figure out what's inside the parentheses. If you have 2 to begin with, you'll have 2 in the parentheses. If you have 3 to begin with, you'll have 3 terms in the parentheses. Well, let's figure out what that first term is. I'll go ahead and I'm going to rewrite it like I did these two and use division. So I'm going to take 4x squared, and as you get better at this, you may not have to rewrite it over here, and divide by that. This divided by this gives you a 2. X squared over x, subtracting exponents. 2 minus 1 is 1. The y's, 3 minus 2 is also 1. So 2xy. Check it. Maybe let's go back and redo it. Maybe you made a mistake somewhere, subtracted wrong or whatever. 2 times 2 is 4. Adding exponents, x and x is x squared. Y cubed times y, y squared times y is y cubed. So that works. Let's go to the next one. Positive 2xy squared. Take our next term, divided by our greatest common factor. Okay, 1, 1. Those cancel. Those cancel. We get a 1. Okay. So then we have plus 1. Okay, all canceled, so you're left with a 1. Multiply it out. If you take this times 1, do you get your original? Sure you do. Okay. All right, so that is part of factoring. Let's go through some examples. And again, we'll keep them pretty easy. Let's look at 17. What could I take out of both of those? I want to factor, and it says check by multiplying. So you multiply it out. You should always come back to the original when you're factoring. What goes into 3 and 15? Now there's not a common variable, so we're not going to have a variable out front. But 3 goes into both of those numbers. 3 goes into 3, 3 goes into 15. So take 3y divided by 3. 3y divided by 3. Take this divided by this, it's just a y. That's all that's left. Check it. This times this gives you that. Perfect. Now, plus 15 divided by 3. 15 divided by 3 is 5. plus 5. Okay, so you take this divided by 3 to come up with this last term. Multiply it out using the distributive property, and yes, you do come down to the original. So you're done. Let's try the next one, 18. What goes into 8 and 24? Well, 2, sure, but higher, 4, yep, but higher, 8. 8 goes into both 8 and 24. All right, so we have an 8 out front. That's our greatest common factor. So what do we multiply the 8 by to get this? 8t. Well, this 8t divided by 8 leaves you with a t because the 8's cancel. So 8 times t is 8t. Negative 24 divided by 8. Negative 24 divided by 8 is a minus 3. And sure enough, when I multiply, I get a negative 24. Okay, so division will tell you what to put, but you check by multiplying it. Otherwise, go back and redo something. Perfect. Let's look at 19. What goes into 12 and 9? Well, hopefully it's not 9 because 9 does not go into 12, but 3. 3 goes into 12 and 3 goes into 9. So our greatest coefficient is a 3. What about a variable? Well, the 12 doesn't have a variable. So it has to be in common before you can take out a variable. So we can't have a variable out front. So let's figure out what's inside. I have 2 terms, so I'll have 2 terms. 12 divided by 3 is 4. 3 times 4 is 12. Negative 9 divided by 3 is a negative 3, but you have that a. When you take this divided by this, you get a negative 3a. So when you multiply 12, 3 times a negative 3 is a minus 9a. So it checks. All right. Ooh, let's look at something with 3 terms. What goes into 22, 4, and 8? Sometimes there's nothing. Sometimes you don't have a common factor, but we do in all of these examples. It looks like the only thing that goes into 22 other than 22 is 2 and 11. So it's going to have to be a 2, okay? Because 2 goes into 22, 4, and 8. So we're going to take out a 2, but because all of those are negatives, one thing that you might want to do is take out a negative 2. Because there's no variable in common, so it's just going to be that. What this does by taking out the negative is it makes what's inside easier to look at and work with. So let's go ahead and take out a negative 2. Negative 22 divided by a negative 2 is a positive 11. When I multiply them, I get that. Negative 4x divided by a negative 2 is a positive, because a negative divided by a negative is a positive 2x. And when you take negative 2 times 2x, you get a negative 4x squared. Take a negative 8 divided by a negative 2. That gives you a positive 4. Why? Because you still have that y there. It didn't cancel out. And sure enough, a negative 2 times a positive 4, y, is a negative 8y. And so you're done. So if you have all those negatives, it's kind of nice to pull out a negative. It makes this a lot easier to look at inside. Multiply it out and check it. All right, let's do 21 and 22, and then we'll go to 1 through 4, and this is probably the longest lesson of all of them. But let's look here. We've got a 7z to the 7th and a 7z. Well, obviously 7 goes into both of those. They both have a z, and we always take the smaller of the two, z to the first. Always take the smallest one for the greatest common factor. Okay, so it's the largest number that'll go into both of them. So let's take 7z to the 7th divided by 7z. Well, the 7's cancel. 7 minus 1 is 6, because when you're dividing, you subtract exponents. So you end up with 1z to the 6th. Okay. And sure enough, when you multiply, you come back to the original. So I'm dividing these, and when you divide, okay, the 7's cancel, you subtract exponents. You get 6. And then check it. And if not, it doesn't work, then try something else. Negative 7z divided by 7z, they all cancel and leave you with a 1. You have to have that 1 there. You have to have that 1. If you have 2 here, you have to have 2 here. 7z times a negative 1 is a negative 7z. You have to go back to the original. All right, let's try another one. What's in common? Let's see, 7 and 14, it'll be a 7. They both have an x. The smallest is x squared. They both have a y. The smallest is y cubed. So it's in common, and it's the smallest. Okay, let's start with the first one. This divided by this will tell you what to multiply by, to go backwards. So the 7's cancel. 4 minus 2 is x squared. 5 minus 3 is y squared. Well, did you do that right? Let's look. 7 times 1 is 7. X to the 4th, y to the 5th, adding exponents when you multiply. So sure enough, you go back to the original. Plus 14 divided by 7 is 2. X squared over x squared, they cancel. Y cubed over y cubed, they cancel. So you end up with just a 2. And sure enough, if you take this, 7 times 2 is 14, x squared, y cubed. Okay, so that's the factoring. Now I said we would come back to 1 through 4. And what 1 through 4 is, it's not so much the factoring as it is coming up with that outside number outside your parentheses. You know, so what's in common here? Well, looking at this number 1, I can take a 3 or a 5. I can't take a 5 out of any of these. So it looks like 3 comes out of here, 3 comes out of here, and 3 comes out of this one. They all have an a, and the smallest is a to the 1st. They all have a b, and the smallest is b squared. And that's what would go out in front of this with 3ab squared. So it's number A. All right. Let's look at this. What's the greatest common factor? We have 18, 6, and 12. I would just pull out a 6, because 6 is the largest number that will go into all of those evenly. They all have an a. The smallest is a squared. And they all have a b, and the smallest is b squared. So there's your greatest common factor. I'm not going to take out a negative because they're not all negatives. So, and the first term is positive, so just leave it. 6a squared, so it's d. Okay, number 3. What goes into 21, 12, and 6? looks like the largest number, this is when knowing your multiplication tables makes things so much faster. It would have to be a 3. All right, 6 goes into these two, but it doesn't go into 21. So we'll just go with a 3. They all have an A. The smallest is A to the first. And they all have a B, and the smallest is B to the first. So there's your greatest common factor that you would pull out front. You would use division to see what's left on the inside. So this is the number to come out, C. And the next one, 30, and then a 6 and a 24. It looks like 6. We'll go into each of those. They all have an A. The smallest is A to the first. And B, they all have a B, and the smallest is B to the first. So that's what you would pull out front, and then you would use division to see what's left, subtracting exponents. So that one is B. All right, well, that's it. We're done. I will open these up. I will open up the quiz. And if you have any questions, I know I tell you, please contact me either through email, or you can contact me, you can text me, and I can meet you on Zoom. I will be on Zoom in my Zoom room, and the link is on just the syllabus in Canvas. If you push that link, then you can join my Zoom room, and I'll be on from 5:30 to 7:30 on Thursday, and then also the next Tuesday. Just try to, as soon as you're done with these, then that pretty much completes everything. And let's see, is there anything else? I think that might be it. So, and if you have questions on your final, I can go through it with you on Zoom. And those final scores that I did include the extra credit, the ones that I recorded. All right, so again, let me know if you have any questions. Otherwise, good luck with the homework. All right, bye-bye.